If 10 decibels correspond to a 10-fold increase in volume, then how many decibels correspond to a 2-fold increase? That is, how many decibels do you need to increase by in order to get the volume of a sound doubling? Now this is a bit of a tough question. The first thing that we should do is find an equation that shows how the intensity of a sound changes with decibels. Now we know that if we add 10 decibels, then we'll increase by 10 times. And if we add 20 decibels, then we'll increase by 100 times. If we add 30, we'll get 1,000. So what we're doing is we're taking 10 and we're raising it to the power not of the number of decibels, but by 1/10 of the number of decibels. So if we have 10 decibels, we'll have an intensity of 10. If we have 20, we'll have an intensity of 10 to the 2, 100. If we have 30, it'll be 1,000, and so on. Of course, we need to have a starting point as well. So we'll call that I0. Just adjust that X. So that means that the intensity of a sound equals I0, the original intensity, times 10 to the power of the increase in decibels over 10. And this will give us an equation for how intense a sound is. Now, if we want to find an increase of a factor of 10 or by a factor of 2, then we should divide both sides by that I0. Right? So that means that if this is a factor of 10, then we need this whole thing to be 1. So x over 10 needs to be 1, so x is 10. If we want the increase to be 100-fold, then we need it to be 10 to the power of 2. So x over 10 is 2, x must be 20. So an increase of 20 decibels will be a factor of 100 in the intensity increase. So in general, we can write down this equation. I over I0 equals 10 to the power of x over 10. What if we want an increase of 2, or a factor of 2, so that we double the intensity? That means that the left side of the equation will be 2, right? So 2 equals 10 to the power of x over 10. Probably the easiest way to do it is with guess and check. Just try different values of x, it's going to be less than 10, until we figure out a number that's very close to 2. But in fact, there's a whole branch of mathematics that deals with questions like this, and that's called logarithms. You haven't learned that about yet, it's year 12 mathematics. But it turns out that using logarithms, we can say that x over 10 equals the log base 10 of 2. I mentioned before that if we take the log base 10 of, for example, 1,000, then we'll get the number of zeros in 1,000. It's like saying 10 to the power of 3 is 1,000. In this case though, we don't have a nice power of 10 that we're taking the logarithm on. We have a 2. So we're going to need to solve this with a calculator. Before we do that though, we can multiply both sides by 10, make it a bit easier for ourselves. And it turns out that there are a whole number of rules and identities that we can use with logarithms, but we don't really need to get into those right now. If you use the log button on your calculator, by default it's set to log base 10. There's another log button called ln, which means the natural log, but that has a base that isn't 10. You'll learn a bit more about it later. So if we take the log base 10 of 2 and we multiply it by 10, then we get a number of 3.01. So that means that if we increase the number of decibels by 3.01, then we double the intensity of the sound. If you want, you can check this by substituting into this equation here. Now 3.01 is a bit of an approximation, but you should get a number that is very close to 2, which means that increasing the volume of a sound by 3.01 decibels will double its intensity, assuming its frequency doesn't change. So with that sojourn into advanced mathematics, we'll finish. So that means we've finished the questions now. We've talked about the amplitude and intensity of sound waves, how loud they appear, how we measure sound, and the sensitivity of the human ear and how that affects the sounds we hear.